Hello everybody, I'm doing the testing on some new resettable fuse, and the resettable fuse, like something like this. It replaced the disposable fuse in the AC main line. What it does is, if it's overcurrent, it will go to high impedance and stop any kind of current going through, or any kind of excessive current going through. So therefore, that's to protect the circuit. And they don't really open, but they go high enough impedance that nothing substantial can pass through. And then when you take the power out, it will go back to normal impedance, and the next time you plug in the AC power, it will pass the current again. Now if the circuit have anything defective, it will go to high impedance again and stop the current. That's why they're called resettable. I got some new one. I want to test them in one of my power supply. I've been using this resettable fuse in my line level component for a while now, but I just got some new one. I need to do some testing. What it does, see that little things over there? That's in series on the live line, and I have the variac set at 120 volt, and this meter is monitoring the primary of the transformer. These two transformers in parallel together is capable to produce 1.6 amps at 8 volt DC, 8 volt AC in secondary. So, and I have these two wire. I'm going to short them together. These two wire, let me see that. Yeah, these two wire, and short them together. I'm shorting the secondary, and you will see the voltage on that meter drop down to very low. Now, never go to zero, because again, the resettable fuse doesn't really open. It go high impedance enough that doesn't do any harm of the circuit anymore until you take the AC power out of it. Now, don't expect any kaboom. You're not going to see any big kaboom. It's a small spark you might see. Okay, I'm going to do a few times. I'm going to show you what happened with the resettable fuse after about 2 or 3 times. You will see the resettable fuse does not go back to low impedance, low enough to pass 120 volt, which is normal. You have to take the AC power off and let it cool down before you can apply AC power again and expect to be 120 volt. So let me turn that power on, and this will be 120 volt. So therefore, this 120 volt applied to this primary of the transformer. So you get 120.4 and 0.5, that's close enough. And I am going to short the secondary. You will see a little spark, but not much. You will see the the voltage on the meters will drop just a brief moment. So the resettable fuse is a slow blow type, so it takes 1 or 2 seconds before it drops down to go high impedance. So that's only 1.2 volt AC applied to the primary now. So that's nothing, relatively nothing. So there's nothing going through the circuit. And if I open it, slowly go back up to 120. That will be the first time. Okay, it doesn't go back up. I might have to take the AC power off. AC power is off. Okay, let it cool down for a few seconds, and see I can go back to 120 volt. Let's go back. That's 120 volt. So to do it again. And this time went a little faster to go to high impedance. It's probably because it's still warm. So I'm going to take it out. Yeah, still fairly high impedance. It doesn't go back to 120. So if I take it off, 10 seconds, 4, 5, 6, 7, 8, 9, 10. 120 volt. And that's how the resettable fuse works. So You don't have to buy any audiophile fuse anymore. As far as I'm concerned, resettable fuse works better than regular fuse because it doesn't have any mechanical clips or any type of things that have impedance. It doesn't have any contact. It's actually soldered directly onto either the PC board. In this case, I buried the resettable fuse inside silicone and then just soldered the wire directly to it. So it's a direct connection. Now this power supply is not done yet, so there are other parts that it will be buried in the silicone, and the silicones are the mechanical fastener holding the wire. In case of anything happen, it will not get loose. So this is not a complete power supply, so just be aware of that. So this is go back to 120 volt now. So that's all I need to test, really. I have been testing a few more times. I have been testing different model, but that resettable fuse is a 500 milliamp slow blow, and I have a 3 amps slow blow fuse in that variac for protection, just in case the resettable fuse doesn't want to do anything and I don't want to damage the transformer. And that's how the setup is, and that's it. That's no kaboom. So you're not having fun. I know that you want to see kaboom, but I'm not going to show you any kaboom this time. Maybe next time. So until then, have fun, stay safe, bye.